hearing?
Yes, it's okay. Fine. Go ahead.
Are you able to see now? Yeah.
Yes, please go ahead.
So this is like, as I mentioned, we know this, in the sort of, in the second chapter of our textbook in food process engineering, when do a course, and we have seen, for example, not only in textbook was, the applications like this. You see the fish being dried at the coastal places, and you have the instances of these evaporatively cooled structures. In fact, IRI, Dr. Roy had developed sometime in 1986 this zero energy cooled chamber. So the theory of this is something, as I said, like in the second chapter, we all studied what is water activity, and we all know that if you keep the water activity below 0.7, then all these perishable commodities, they store well, and you can sort of, not have any of those microbial attacks, which really is one of the culprits. So water, then to the water, you have these microbes, and microbes spoil your sort of, happiness of the farmers, that they produce whatever produce they have. So during storage, so, based on the perishability of the material, let's say, your cereals can last for 2 to 3 months without having to sort of store in any cold place. But if you have fresh vegetables, 4 days, 5 days at the most. If you take tomatoes, for example, you might have a shelf life at ambient temperatures of 3 weeks or so. But if you really want to extend, then sort of, you really have to sort of put them in the cold. And often at times, for example, that the villages have still within India are struggling to have a sustained electricity supply and things like that. And you will see. So this is something which I have just shown what we know from science of water activity. And now the first, for example, application I'm going to tell you about is the hot air dryers. Okay, and the hot air dryer, how we sort of integrated or solved a problem expressed by an industry. So this is such a live problem. I'll show you some images which I received just 2 days back, where we are sort of, so this is the case one, development integration of hot air dryer for drying treated cotton stock post-treatment in ozonated water. And in a minute, I'll tell you why we are doing this ozonation of cotton stalks, which normally are burnt, or at the most you have briquettes, for example, which are used in the combustors, in the boilers and things like that. But we have developed a new application of value-added product from this cotton stock. Because if you, for example, make briquettes, you might get at the most 5,000 rupees per ton. Whereas if you sort of make an animal feed from this, you can go something like 15,000. So 3 times higher, 15 to 18,000 rupees per ton. Okay, you can get that. However, all of us know, those who are from Vidarbha area, cotton growing areas, we know that cotton stock gets as hard as wood because of its lignin content. And therefore, no animals would want to sort of touch that, because they don't eat woody substances. Therefore, we sort of did some research, and we have developed a technique or technology I'm going to talk in a minute. And the case 2 is like, we call it typically NPD, new product development. And we have sort of, this potato puffing unit for small agro entrepreneur. And I'll try narrate you, I'll take you to that. So this is the case study 1. I said to you, the project on making animal feed unit from cotton stock. Last almost 5 years, we have worked on this, and it has traveled its own journey. First in the lab, we did trials for something like 1.5 to 2 years. And what trick the ozone does is it chops the bond between lignin and cellulose. So as a result of this chopping the bond between lignin and cellulose, the cotton stock, I think Professor Mayande would so much appreciate, because he lived in Vidarbha, and the same as Vijay Patil. Those who have lived in Vidarbha, they know that cotton stock farmers, then they're so much bored or tired that they want to release that land for next crop. They just burn it. So and what happened was, this was kind of a serendipity for us, like when we were working on this, reducing the microbial load using ozone for tomatoes. We just sort of tried this, and it worked. And subsequently, with the Nagpur Veterinary College, for example, we did a pilot plant and studied it on small ruminants like goats. And it was sort of, a kind of such a a pleasant sort of, outcome of that project, that the Maharashtra Science and Technology Department, RGST, as we call it, Rajiv Gandhi Science and Technology Department, gives a 2 crore. And with BIF, which I mentioned to you in the beginning, the NGO, we are now developing a plant which is in the process of working there, is for bigger ruminants like cows. So with goats, for example, our study outcome was how fast is the weight gain. How fast we can gain weight using this animal feed. And we did a systematic control trials that we compared cotton stock versus the other sort of, conventional feed. And we did that. And now we are sort of, and why, for example, we need a dryer here is because we had done this. This is a ozonated water, which does the trick. And the initial design was to have the sun drying, because in rural areas, normally there is no sort of scarcity of land. But you see what has happened in this rainy season. This is a picture of yesterday. Even in dry, for example, district like Pune in Western Maharashtra, it doesn't rain like Konkan or Mumbai. Look at the fungal attack that you have on the treated cotton stock, because the treated cotton stock, which is removed from this ozonated water, it has the initial moisture content of something like 85%. And we need to bring it down to 15%, because the briquetting machine has to sort of, work. And the briquetting, other ingredients like, the oil cakes and things like that, which we make a complete feed, it has to brought down from 85% to 15%. So what we have done is we have sort of designed a simple dryer which has a capacity of 200 kgs, because that is what they want to make. In 5 hours, for example, we sort of bring the initial moisture content from 85 to something like 15%, which is something which our pelleting machine can take with other ingredients. Because all food processing engineers, agro processing engineers will understand that if you have various ingredients, the moisture content should be kind of sort of uniform. You can't put something with 85% and something with 10%. So we had to sort of, because we are making this pellet in the same way as the animal keeping farmer has been used to. So there is the animal feed which comes in pellet form. So we have not changed much there. So 60% of our ingredient that goes into making this complete feed is this roughage, as it is called roughage. And cotton stock was never used. And last 5 years, as I said, we are in the process of doing these trials with this. So this is, I sort of demonstrated to you, it's a live problem, how, for example, a hot air dryer can be designed and integrated in an agro industry to solve a problem. Now, the second case where we integrated the hot air dryer is what we call in NPD, is like, for an agro industry entrepreneur, we sort of said that you can make puff potato cubes. And I don't have a video, I don't have time to show you a video, but these are again something which is known in other chemical engineering industry. For example, this is a fluidized bed dryer. Okay, and the end product you get is something like cheese balls, which are rounded. So you can imagine, you take potatoes, you cannot have round balls. So what you do is you take cubes of 1 centimeter by 1 centimeter, 1 centimeter. I mean, this is the average size. You can have up to 2 centimeters, 2 centimeters to half centimeters. As an academic institute, we tried various combinations. So 1 centimeter by 1 centimeter gives you a kind of a snack which is similar to the cheese balls that all of us have seen and used. So this is a unit that we developed, and this had a hot air dryer. As you can see it in this photograph, this is a blower which blows in the air in this a compact air heater, and this air which is coming out makes this, this is the container where drying and puffing takes place, and the potato cubes dance inside this. And as you can see in this performance evaluation, so this is again another sort of, cut schematics of this. You have a blower, then this is a compact air heater, and it sends the air. And what we want to do is, like, there is different drying temperature requirement is different, and the puffing temperature requirement is there. So as you can see, between 3 to 4 to 5 is what you call HTST process, high temperature short time, which is like 4 to 5, which is that 170 degrees Celsius for few minutes we keep it, and you get that puffing effect. Otherwise, in a batch of something like 200 minutes, about 3 hours, you have most of the time is drying. Okay, so these are various steps, and the process engineer, you always do some kind of a TT diagram, time versus temperature, and as you can see it here, and this is entrepreneur from Vasai has taken it, but that was another story, that why he could not capitalize on this, because simply he did not have a 3-phase connection in Vasai. But this is a second application, for example. I have just actually taken from A.S. Muzumdar's handbook a selection of dryers, and I don't have to deal, I'm not going to read through how, for example, one goes and selects a type of a dryer. So like in our application, we had the fluidized bed dryer, as you can see here, the fourth one, fluidized bed dryer for this potato puffing, because it gives you higher mass and heat transfers, because you want to come from 85% to 15% moisture, and at the same time you want to sort of use minimum electricity, so because in drying, one of the important thing is like energy use, so you want to have a specific energy consumption which is lower. So there is some kind of a sort of this is, I have just taken it from A.S. Mujumdar's handbook, dryer handbook. Those who want to sort of work with industry, select a type of dryer, and like what we did for our ozonation project on converting animal feed from the cotton stock. That is how we designed, and Now with this, now I will come to my technology 2, after having talked about this hot air dryers, that how intelligently you can use. See, what I tend to tell my students here during the teaching here is that enormous amount of literature is available in the handbooks also. You just only, it is waiting for developing those applications. I mean,
and you have 3 minutes. Sorry,
3 minutes,
you have
yeah.
3 minutes.
So Perry's handbook, for example, in chemical engineering, will give you, something like 800 pages. You have so many tables, so many data, and all that you can use. So this is a simple application. What you see here is a evaporatively cooled structure. What we have, what is innovative in this? What is new in this? We have taken the locally available laterite blocks. People build houses of this. So what we have said, that because this is thick, so you keep a gap in between these two blocks, which will allow the air to move. And we just simply took a drip irrigation system and dripped the water frequently using some automation process that I'm going to, and we did some kind of a needs assessment, like why the farmers, for example, 20 farmers could own the 3-ton structure to store their vegetables of 5 days product. And so they can sell it in a markets which are at distance and get the revenue. So these are the kinds of vegetables that the farmers stored in this. This is how the structure looked like, of 3-ton capacity. And then, of course, like we did an academic study, that what kind of temperature variations. As you see, for example, the red dotted line shows you the temperature, which is of 20 degrees Celsius, and which is like, you can get something like, 10 to 12 degrees Celsius of delta T, which is largely good enough to extend the shelf life. And along with temperature, all of you know this fundamental, that also relative humidity has to be higher. So, on Nukkadwala vegetable shop, in months of April, May, he just keeps sprinkling water on it. What he does is he increases the relative humidity so that the vegetative cells are kept, and you don't have that wilting or shrinkage of those vegetables, and he can. So this is some little summary of this evaporatively cooled structure. You have 3 tons, and I said 20 farmers, because that's based on what they produce. I mean, they get about 20-30 kilos each. And so they can own it as a farmer producer company to store it for 5 days and have additional revenue. This was the size, and water required is about 250 liters. And you can also recirculate the water after filtering. And the installation cost was 1 lakh. And we just did some calculation. This was just last year. Samir did his MTech and passed out, and sort of, this is in the first year of use, but we do know from the collector's office in Palghar that they are using it, and the payback period is about 4 years, taking that delta revenue addition. So Syed, this is my last slide. I'm acknowledging my student who helped conduct these needs assessment, farmer group, like focus group discussion with the farmers, and sort of telling them the use of this, making the measurements in the field. Thank you for patiently listening to me. and I will, Dr. Syed will sort of, announce when
Okay.
you